Here we go. We have a question, make array elements unique. So you have given an array and your task is to find the minimum number of increment operations required to make all elements of the array unique. That is, no value in the array should occur more than once. In one operation, a value can increment by one only. So in this case, we have this these elements duplicate. So if we increment this number by 1, we have all the unique number and the total number of operations required is 1. In this case, first we need to increment this number, so it will become 2. We have done one operation, now this is 2, so we have to increment one more time, it will become 3. We have done two operation till now, so we have 3 and previous number is 3 also, so we have to increment current number by 1. So now the answer is 3. All the elements is unique now. So in this case all the elements is unique, so we don't need to do anything. So let's build the approach. So let's suppose we have this test case. In this test case, uh, the array the array element does not need have to be sorted. So first we need to sort the array. Sorting is very useful because we can now track the previous element. So first step is to sort the array. Now we are starting from this value. We cannot compare this value with the previous value, so we just need to store this value. So let's say this is our previous, so our previous is 1. In this case our value is 1, so we need to check, is our current number less than or equal to previous? Why less than, I will tell you, but we need to write a condition, is our current number less than or equal to previous? In this case, yes, our current number is equal to previous, so we need to increment current value. So by how much? So this number have to be previous plus 1. This number this number have to be previous plus 1. So previous plus 1, we need to do this many operation, but this many operation is already there, means arr of I. So in this case 2 minus 1, we need to do one operation here. So we need to do one operation. Then in this case we have to do one operation. After doing one operation, the current number is equal to previous plus 1. We have incremented one number. Now previous pointing to current value, not pointing to but containing the current value. So till now we have 2 as maximum. Now we have again 2. Is current number less than or equal to previous? Yes, so we need to increment some operations. Current plus previous plus 1 minus already having value, means current value arr of I. Previous plus 1 is 3 minus 2, means we need to add just one value. So now the value will be 3 and previous pointing to previous having this value, so previous is now 3. In this case our current value is less than or equal to previous, so we need to add some values here. So previous plus 1, previous is actually 3, previous is actually 3, previous plus 1 is 4. So here now the number have to be 4. Here the number have to be 4. So we need to add, we need the number to be 4, but two number is already there, so we just need to add two more values. So after adding two more values, current previous is 3. Here the number will be previous plus 1, because we want the number to be previous plus 1. We want the number to be previous plus 1. We need to add two more operation. So here the number will be previous plus 1, which means 4. Now our current value is less than or equal to previous, so we need to add some more values. We need the number here to be previous plus 1. Here we have 4. I want 5 here. So the value should be previous plus 1. Previous is 4, plus 1 is 5, minus current value is 3. So we need to add 2 more values. Then the number will be 5, and previous pointing to previous having this value, which is previous plus 1 5. I want the number to be previous plus 1, so that's why we have this. Now let's suppose we have this number. So in this case what I want is 6. I want 6, but 6 3 number is already there. We just need to add 3 more values. So the number will be the number will be uh, 6. The number will be 6, and we have added 1 previously, then 1 previously 2, then 2 4, then 2 6, 6 plus 3 9. So we just need to return 9. So let's talk about this test case. And in this test case we have previous starting value as 2, and we have this number. Is this number less than or equal to previous? No, this number is greater. So we just need to set our previous to current value. Now we have this. Why we need to set? Because the sequence will start from 4, and all the other numbers on the right side have to be greater than current number, which is 4. So now, is our current number less than or equal to previous? Yes. So we need to add some more values. So previous plus 1 minus ith value, which is equal to 5 minus 4 1. So we need to add one value. The previous will be 5, which is this value. Previous is 5. uh, One thing to remember is we are not updating our input array, uh, although we are using the sorting, but apart from it we are not changing the values. We just need to find the count, so we can maintain the count in a separate answer. So next, we have 17. So this number is already greater than previous number, so now it will be 17. Next we have 17. So I want 17 plus 1 18, 18 to be here, and 17 is already there, so we need only one operation. So now here the number is 18, here the number is 18. We have 18 here, so 18. I want 19 here, so 18 plus 1 minus 18. I need one more operation. The number is 19 now. Previous is 19, so we need to add 3 values. So we just need to add return 3. So let's code this. So first we need to sort the array. Next, starting from the 0th value and a answer, and we start a loop from one value. So if the current number is less than or equal to previous, if the current number is less than, means we need to add some values. The value is previous plus 1 minus current value. I want the current number to be previous plus 1, and we have already ith values here. So uh, we compute this and store the answer, increment our answer. Next, the value here is previous plus plus. Else if the number is already greater, so we just need to set our previous. At the end, just return the answer. So let's give it a try, and let's talk about time and space complexity. In this function we are having a sorting. So we are doing sorting. So the time complexity is n log n, space complexity constant. Code is given in the description box. If you like this video, give it a thumbs up, subscribe to this channel, and thank you all for watching.